Hello students, in this video we shall discuss about fundamental theorem of arithmetic, and earlier we have already discussed Euclid's division lemma. So today let's learn about fundamental theorem of arithmetic. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. That means, you see, every composite number. So whatever composite number you think, that can be expressed as a factor of or as a product of primes, and as a product of primes, and you see, this is unique, and the order of factors, this is also important here. So you can you have to remember this statement. Now let's go for one example. Let's take 40. Now if we factorize 40, what we have? We can get 2, then we have 20 here, so again we can take 2, so it will be 10, then again 2, so we have 5 here. That means 40 can be written as 2 into 2 into 2 into 5. That means it can be written as 2 cube into 5. So this is about factorization and how we can express 40. You see, 40 is a composite number, and you see 2, 5, these are prime numbers, and we can write it also 5 into 2 cube, no problem, because here if I write it in this way, 5 into 2 into 2 into 2, I think there is no problem. It will also lead to the same answer, that is 40. That means when we are factorizing a number, then order may not be important. We can change the order, but what you see here, 2 and 5, the prime factors are 2 and 5, and this must be same, and no one can represent 40 with other prime factors. That means you cannot factorize 40 by taking all 3 or 7 or something like that. You cannot express 40 with other prime factors. That's why we are saying that it is unique. This factorization is unique. So 40 has only two prime factors, that is 2 and 5, and it can be expressed with the prime factors 2 and 5, where the exponent of 2 is 3. So this is what the fundamental theorem of arithmetic says, that this factorization is unique. Let's take any other example. Let's take another example. Suppose we have 65. That means it can be written as, you see, here 5 is there, so 5 into 13. So both are prime numbers. So here it can be written in the form of the product of 5 into 13. Let's take another example. Suppose we have 75. You see, 75 means it can be written as 5 into 5 into 3. Okay, that is equal to 5 square into 3. And we can also write it as 3 into 5 square, no problem, because order is not so important, but the prime factors are important here, and 75 can only be expressed by 5 and 3. This is what fundamental theorem of arithmetic says. Now let's move to one important formula here. You know how to find out SCF by your Euclid's division lemma, and also you have learned how to find out SCF by your factorization method. Here once again we shall deal with that formula, and we can whatever you have read in primary section, that is SCF into LCM equal to product of numbers. you might be remembering this formula. Again, in this section, we shall again deal with this formula. So let's take one example. Find the HCF and LCM of 6 and 20 by prime factorization method. Now we can express 6. 6 can be expressed as, you see, 2 into 3. That is 2 to the power 1 into 3 to the power 1. And 20 can be expressed as, you say, 2 square into 5. So 2 to the 4, 5 is 20. Now SCF. SCF means what? It is the product of, we can say it is the product of the smallest exponents, the smallest powers. That means here we can say, you see, here we have 2 and here we have 2 square. So the smaller one is 2. And you see 3 is not there and 5 is not here. So common factor here is 2 and it has the smaller exponent is 1. So we have taken exponent SCF as 1. That means we can also say that HCF means it is the product of the common factors in which the exponent is the smallest. And again LCM means here we have to take the highest exponents. Here 2 is in both 6 and 20, so we shall take the highest exponent, that is 2. So 2 square, here 2 square, and 3. 3 is here we have exponent 1 and here we don't have 3. We can take the highest one, that is 3. And in the same way we can take 5 to the power 1, that is, so we have the LCM equal to 2 square into 3 to the power 1 into 5 to the power 1, that is equal to 4 into 3 into 5. So we have LCM equal to 60. So in this way we can use fundamental theorem of arithmetic to find SCF and LCM of numbers. So thank you in this video, and in the next video we shall meet again with the solution of exercise 1.2.